Now let's use our knowledge to do some example reactions of monosubstituted benzenes. So what you want to do is figure out if the group is an activating or a deactivating group and an ortho-para director or meta director. From there, you want to draw the products of the reaction. All right, we'll start with phenol. This is one that you've seen before, and we do a bromination. The catalyst is added, although with phenol, because OH is a strong activating group, we don't have to have that catalyst. But it's fine to have it. The OH is an ortho-para director, meaning it will put the new group ortho to itself and para to itself. But remember that with that really strong activating group and a halogen, we end up with trihalogenation. So the product of this will have the phenol with 3 bromines. In contrast, if we do a nitration, the phenol is still a strong activator, it's still an ortho-para director, but in this case, because we're doing a nitration, we're only going to get mononitration products. So what we'll draw here, we will get an ortho product. So here's the OH with an ortho nitro, plus we'll get a para product. So unless it's a halogen, just expect to draw the 2 separate products. Down here on the bottom left, we have a bromination of this. We have an ester on the ring, but of the ester, the carbonyl is directly attached. So because of that, this is a deactivating group, and this is a meta director. So that means this is going to direct the new bromine meta to itself. In this top example, we have phenol, which is a strong activating group. It's also an ortho-para director. And we're doing a Friedel-Crafts alkylation. So in this case, we're going to get a product with the phenol that has the ethyl group from the Friedel-Crafts, and that's going to be added to the ortho position, and then we'll get a second product where it's added to the para position. In this particular case, the carbocation intermediate that you would have gotten is this, which isn't going to rearrange, so we didn't have to worry about a rearrangement product here. In the second example on the bottom left, this is another Friedel-Crafts alkylation, but we have this amino group. And recall that we learned that amino groups are not compatible with the Friedel-Crafts reaction. The reason is because it ends up reacting with the catalyst faster than the catalyst can react with the alkyl chloride. So no reaction here. And then in our third reaction, this is another Friedel-Crafts, but we have the cyano group, which is a strong electron withdrawing group. And again, remember that Friedel-Crafts reactions, they're pretty finicky. They are not compatible with strong electron withdrawing groups. So no reaction here. These next 2 examples give us important features that are going to be useful when we start to do synthesis. So what we find is that if you have a really bulky group, what that's going to do is it's going to block out and hinder the positions ortho to itself. So there are several bulky groups out there, but for us, we're only going to need to know two. That is the tert-butyl group and the amide group. Those two things we're going to consider our bulky groups in this class. So if we have tert-butylbenzene and we try to do a Friedel-Crafts alkylation, the tert-butyl group is an alkyl group. It's an ortho-para-director. But because it's so bulky, what it does is it takes up a bunch of space here, and effectively it blocks out these ortho positions, making them unreactive. So the only reactive position is the one para to it. So when we draw the product, we have our tert-butyl group, and then at the para position, this was a Friedel-Crafts alkylation, we'll get the methyl group. In our second example, we have this amide, and again, we're treating this as a bulky group that blocks out the positions ortho to itself. And keep in mind, even though it only looks like it's kind of hovering over here on the right, there's free rotation around this bond. So at any given time, it could be over here or over here blocking those positions. So if we take this, and this is a moderate activating group because of the lone pair on the atom next to the ring, and it's an ortho-para-director. Well, the ortho positions are blocked out. But if we do the reaction, we can get a para product. So we'll get parachlorination. This particular amide substituent is going to be really important when we do synthesis because it will allow us to prevent groups being added at these positions, and then we're going to find ways to take this amide group off and transform the nitrogen to other things.